All right. Well, with that, everybody, thank you for coming back and welcome to Jetson AI Lab. Excited as always to be here. Surprise guest at every turn and avenue. This is Dave's Unitree humanoid, Stanley, that he's so kindly brought on the show. Today, for those of you watching the recording, is October 15th. We had meant to cover LeRobot. Chitoku has the Kosharm setup working and was able to train that to pick on over in Nano. I believe the NASA JPL guy said they might stop by and show some things. New Isaac Sim plugins they have, and Johnny and I have been real busy rebuilding the whole stack for Jetpack 6.1 and latest CUDA stuff. We're finally clearing all of that and can get back to the robot learning algorithms, which looking like this group has a new humanoid to power. So any of you guys have any questions that you want to start off with Dave here for? It seems Unitree has sent Dave a demo unit to play around with open source humanoid tech. That's amazing, and hats off to them. Dave, you want to give us a little background on how this came about or what your plans are for it?
So how this came about is I've done some driver development for them before, so we have a relationship back and forth.
Nice. Was it ROS driver?
So I reached, yeah, so it was the ROS driver for the Z1 ARM.
Cool.
So I did the ROS one driver for that, which they have on their GitHub.
All those good deeds. Yeah.
Oh yeah. So so I reached out to them wondering if I could buy one, and they said yeah. So now I have one.
Awesome. Well, depending on how it goes, you might be next.
Oh yeah. So apparently there's under 20 of these in North America. As far as I know, they weren't super specific with numbers, but they said roughly 20. It's got a LiDAR on the head and a stereo camera. So as far as plans for it, my first plan is for Halloween to turn it into a Terminator. Because you might as well just go ham.
Just ripping that Band-Aid off. Okay, I get.
Yeah, might as well just go for that. I mean, there's a company in I think it's China called Skynet. So
oh my, Dave, you're killing me with the PR. I guess you're going so far with it. It's like fast fiction, so it's doesn't even. All of these ones are, I believe, they could make look a little more friendly. So maybe after,
well,
Halloween, you can do
comes with clothes. Huh. It's got basically a shirt on it.
Okay.
And then a bunch of all of this is padding as well. It's all foam over here and over the legs. So hopefully I can strip that down and then. Yeah.
So he came with the shirt. So he came with the shirt. I thought that you had added that on to make it look more friendly.
No, it came out of the box like this. I was hoping it came with a Unitree t-shirt like they have in all the demo things. But no, it's just this burlap shirt, straight jacket kind of thing.
Nice. I think you need to get Chris to make you a cool head for it. Mm-hmm. Yeah, this is all coming together. That's wild. And this is a huge opportunity for not only you and this group, but all of us working in open AI community for this. So yeah, we hope to support you with whatever you need. I know that you've done quite a bit of LLM voice agent stuff, and you've been through it at this point, Dave, and won that GLaDOS contest, right? So you're aware of the challenges and everything doing this at the edge, and I think it's wonderful that they've enabled you as an ambassador of the community to go off and show the world what we can start to do with this stuff. That said, you were showing the locomotion early right before we started, and maybe you can show it walking again. And I'm not sure what other capabilities their SDK has, but maybe doing some reinforcement learning locomotion in Isaac Lab or something could help it walk more smoothly. You still there? We lost you on video. Maybe you're changing the camera around. Looks like he might have disconnected, might be
The
joined
robot
back.
already took over. Yeah, that was all.
That's all right. In the meantime, what we had actually planned to cover was Chitoku has gotten the LeRobot Kosharm demo working, where he trained it with ACT learning policy, similar to like the diffusion policies or OpenVLA that we've been working. But this one is all running on board Orin Nano, which makes it very accessible for new people getting started. Chitoku, are you there? Do you want to screen share, or how would you like to run this demo today? I believe you might be muted, Chitoku, if you're.
Oh, sorry. I was on the
There you go.
mute.
There you go. All right.
Yeah,
Cool.
I'm going to share a slide first.
Okay.
And then cut into the actual demo with the hardware.
Okay.
I'm gonna
Thank you
just
for
give
doing
a sneak peek, and oops, this
We'll
is
make
a setup.
Okay. Make this.
Hope people can see, but yeah, I will later again go over. You know, hopefully I get to demo with this. Granted that it hasn't been trained long enough, maybe, because I set up something. I added new hardware. But anyway, let me cut into my presentation. Give me a moment. So again, HuggingFace LeRobot. Obviously, it's from HuggingFace. LeRobot is defined as like they say it's a tool for all the real world robotics in Python. So it has all the tool for building model, capturing building data set, and all the other convenient stuff. And then from my point of view, it's a great software framework to work with all the state of art diffusion model or ACT, those for behavioral cloning for robots that many people are now interested in. So
I kind of view it as just like the Hugging Face transformers analog to robot learning. And when we initially started going through this, it was like everybody has their own simulator, all the repos recreate a lot of things. And this is just a real breath of fresh air to that they've taking a lot of those robot learning algorithms and like converging them in one repo, kind of like Hugging Face transformers, and along with all that great hardware kits that you've been trying here. So hats off to them, and we're happy to have been able to get this working.
Yeah, and what's great about this is it can actually work with the physical real-world robots, and they are demonstrating it was very inexpensive, easy to access robots. This Kosh arm you can build under $500. So yeah, that's another reason why a lot of people now feel like getting into physical AI finally.
Just like us, it's important that it's available to like everybody, and I think that was a good idea. You trying this with the Orin Nano, because that if you're a student at $299 plus that ARM kit, so for like $750, you can get started doing all this latest robot learning with transformers, which is actually quite amazing.
Yeah, exactly. Everything all in one, less than $1,000. Yeah, fine. It suddenly sort of opened up the whole world to even like educational communities. So we are very excited about it. And just to sort of like explore what LeRobot is has to offer in terms of supporting or controlling the real world robots. So everything is sort of like documented on their official documentation. This is a big README file that everybody is going through. And basically, it sort of like get decomposed into these 5 steps. I'll sort of walk over so that people get to have like some idea So the first is to, of course, obviously to get the robot arm. Kits available. Robotics is actually selling the kit on their website, both the leader arm and then the follower arm. One thing to note is you still need to 3D print the parts. Hopefully somebody actually make it even more accessible. But in the meantime, yeah, everything is available online. And after you get your arm ready or assembled, what you would go through is the calibration phase. And there are some like manual steps here, but they are trying to make it easy. I tried to make it easy by putting together a Jupyter notebook. So that's something you can follow if you're interested in.
That's kind of like you did
Once
with the
you're
Jetbot,
done,
right? Right, Chitoku? Which is like kind of what you and John came out of from the Jetbot, which was a similar kind of effort to enable AI.
yeah, it kind of like spiritually, at least I feel like I was getting into that, yeah, vibe again. But there are actually more similarity. I will go over more. Yeah, but like this is really community driven, which I really like. So yeah, at the end of the this step, once you calibrate your arms, what you can demonstrate is teleoperation. So that is you control your leader arm so that the follower arm just follows the exact movement. And the idea is you try to make the follower arm perform a certain task by manipulating the leader arm. So that's a very unique sort of mechanism they employ. So the real part is, yeah, data recording, right? And it's as simple as calling this Python script. And like I said, the way you build out your data set is to, set up your environment and then control your leader on the right here. And yeah, you would be staring at the follower arm and pay attention to where exactly your arm tip is with respect to the object. And yeah, it's almost like a play or a game of, I don't know what that would be, but to control the follower arm to, in this case, throw a green piece of Lego into yellow bucket. That's the sort of task I came up with.
People
And then
love
once you, yeah, by the way, yeah, you can employ your volunteer to, build out your data set. After all, you need to like go through like 200 episodes or something. And kids love to do this. I mean, for them, it's like a game of, arcade. So yeah, let them do. And once you create your own data set, you can visualize, you get to like inspect how it goes. So each sort of graph or like lines shows the angles of each motor. And you see like some are in fainted color that's depicting the follower arm. So I guess this yellow is sort of like this gripping motor. So once it actually grabs an object, it doesn't close all the way. So you see this divergent here. But anyway, they provided this nifty tool to visualize your data set. This comes handy even when you're inspecting your validation result. So you would train your model. They are packaging, I mean, LeRobot packaging a couple of models. And I have been primarily working with ACT. And our understanding is that they are packaging their sort of like own implementation of those model might not be like up to date with upstream. Is that right, Dusty?
Yeah, it's like Transformers where it re-implements them. And a lot of times the upstream original ones don't get touched after. They might get like a README update with like their latest publication. But many times it would seem common in this robot learning circles that have their own GitHub IO page, own repo, next project comes along, whole separate set, and it basically isn't touched or really upgraded to the next version. So, re-implementing it and bringing it in is great if they can like match the training accuracies and have gone through this in parallel. Like, well, you've been bringing up LeRobot. I've been going through like the original repos for like the diffusion policy and 3D diffusion policy and like those cross former and those, and they all have like their own sims. Some work because some work, some don't. The ones that don't typically use like old Majoko, and they were actually like quite difficult to all get building and running. So having them in there is really nice. When it scales to the bigger ones like the VLAs, we'll have to see about how that's all architected and stuff. It would be great to chat with these guys at some point. I actually see in the meeting here that Remy Candine, one of the primary authors of the project, was listening in. I know they're busy getting ready for this hackathon in France at the end of the month for this. So if any of you guys are in Europe, yeah, there he is. Remy, thank you so much for everything that you've done with this project. We love HuggingFace, obviously, and everything about your message. So at some point when things calm down for everybody here, we can chat about how best our two communities can like contribute together to build this project out. But for now, keep up the awesome work. Okay, Chitoku, back to you.
Yeah, thank you, Dusty. Yeah, you can actually perform this training on JETSON. I verified it runs on, at least the ACT training runs on JETSON Orin Nano, 8 gigabyte. So yeah, like really, it will really make up the whole all-in-one kit to go over to cover the whole workflows of LeRobot working with physical robot. And if everything goes right, this is what you should get. Your robot performing exactly as you instructed, just purely based on the vision input. All right. So
that is cool. Like this is actually from vision. Sometimes with these RL ones, it's hard to tell if it's just like using the state. It's like high dimensional. So I think some of these are like 84 by 84 or up to 224. So over time we can ramp it up. But like that is key here. Like it is from like the camera.
Right. And because this is from camera input, camera placement and the configuration, field of view kind of matters. I went through some of it and learned a couple of some insights, and so I'd like to share with you later. But before like really talking about what what was needed for making it work on JETSON, I'm just sort of like comparing the possible platform. So you can do this on x86 machine. That's probably most straightforward method, and you'd get to work natively on that, not in the Docker container, and you'd have like a added benefit of being able to utilize a powerful GPU if you have like a big desktop machine or even RTX laptop. So yeah, training, you can like really speed that up. MacBook is also supported, and I believe that's how what Remy of LeRobot or HuggingFace is actually using for most of the demonstration. And it says that it even supports training on MacBook using MPS. I personally haven't like really tried, but that's supported. But they also sort of like, they mainly show the cooler way of training the model, which makes sense. You want to get this model like trained first, or want to see the result of it, right? So I guess more common way is to sort of like upload it to the cloud, some instance, and then get it trained fast, and then get the result on your machine to verify or evaluate. So just sort of like gives a hybrid of those, right? It has the main thing is it has a CUDA GPU, CUDA capable GPU. So you can even carry out the training on device. And this comes handy, especially this kind of thing. If you think about the actual workflow, or industry application, you'd be sort of like going through this cycle of fine tuning or like tuning your model by adding more data as you see necessity when evaluating. So yeah, I think this is a great sort of benefit of having everything in one computer than not relying on other infrastructure.
I know in the video Remy posted where it was like folding his clothes. I think it said he did that on a MacBook in like half a day or something. So that all seems like reasonable for people and like being able to get started with that. And yeah, when in the previous studies we've done on stuff like the OpenVLA, you can just get endless the number of tweaks and retrainings that you can do, and you iteratively build that up over time. How long did it end up taking, like the training? I think you said you did 200 episodes.
Yeah, so initially I took like 200 episodes. And yeah, I went through 80,000 steps or iterations or epochs to, get this trained, the ACT model trained. And yeah, the result was what I showed earlier. So yeah, that's probably around the number of data set and then number of hours you'd need to spend.
Well, how many 80,000 steps? How many hours did that take to train on the Orin Nano or whatever machine that you did it on?
Actually, I didn't like really train all the way on Nano.
Okay.
I actually used JETSON AGX Orin and the JETSON machine. Yeah, to speed that up. But actually on A6000, it didn't take even 3 hours to go through the whole 80,000 epochs.
Okay, but it still took 3 hours on an A6000. So feasibly, it might take like all day on an Orin Nano, which is still. Remember when we did like JetBot and these object detection training and stuff? It was normal that the people would like let it run overnight to do that, and that was acceptable to them because they were getting in at the lowest price point possible, and like you're gonna make some or like Google Colab, you could probably do this through if you wanted to speed it up. But to your point, yeah, once you start like iterating and doing it a lot, you will want to accelerate it however you can, and hopefully we can look at further optimizations for that, like flash attention or other things in there. But it does look good. And it'd be interesting, like, does it plot the loss curve for you to see, like, did it really need all 80,000 steps? Or I know you're just really getting into it with evaluation of, like, the success ratio. There it is. Okay.
Right. LeRobot sort of supports the integration with WNB. So,
yeah. That's nice.
Yeah, once you log in with your credential, it just sort of uploads everything.
Yeah, I think I see it at like the base of the curve there. It's like 100K steps. So yeah, you're probably right that it needed like all 80K. And I think Nigel is probably the one of us that's most experienced with ACT to really be able to like characterize this. How many GPU hours per task does it normally need? And I know he said he started working in 3D with it, and that started a real boost. But also, it might not be our role at the moment to like dig super in on any quite one of these, rather than get everybody started and available on all of them, which we're kind of like rounding out our support now for. And as we do that, new ones continually come in too. So. We're trying to.
I guess this is something people can sort of like looking into it. And there are many variables. Even the number of cameras input is a variable. And like from my experience, the more camera is better. So yeah, there are many things that people want to experiment and then find out what actually improves the performance. All right. But yeah, making it run on JETSON would be great, but there were some challenges as well. And we added some improvements on JETSON container to support LeRobot. some of the thing. Dependency is pretty straightforward. It wasn't that bad, but you'd need this package of PyAB. So this is something we added as a separate package. Well, actually, Dusty separated it. Thank you for that. On JSON containers, along with the FFmpeg that PyAB is depending on. So those are there. This is necessary because they are using LeRobot is compressing the series of image into video file for the later sort of consumption for human to evaluate, watch. So that's really everyone video encode, but that's happening using CPU software encode. So it takes some time. Pulse audio is now supported on JSON container because, again, LeRobot is using this speech dispatcher for making a TTS output. And it's actually pretty good. When you are going through 200 episodes, you over time get lost. Like you don't know where you are, what's the status of it, what's the next action you need to perform. So like getting an audio cue, despite its computer 80s voice, it's pretty useful. So you want to enable that, and it is now supported on JSON container as well. You do need to connect two devices, so that's sort of taken care by giving a UDEV rule. It's a small thing, small improvement. And to be safe, you may want to have a bigger swap file. That was actually needed for my training of ACT model on JSON Orin Nano, so that's there. I wanted to work with CSI cameras, so I supported CSI camera in such way that JSON container presents CSI camera almost as like a webcam. So from application point of view, it is available as just another V4L2 devices. So,
Chitoku, did you see how much RAM it was using? All told.
For the webcam conversion?
No, for the ACT training. And like, what was the batch size that it? You stuck with the defaults. I don't know. It's something we could also.
The thing is, it's not constantly using the swap file. When it's loading up, it sort of like step out from the 8 GB boundary.
Okay.
So that's how swap file was being used. But I didn't like really keep the good metric of RAM usage over the course of training.
When I was messing with the diffusion policy one, that was actually pretty low. It was only like 4 to 6 gigs, but that was 84 by 84 pixels and a batch size of 8, I believe. But hey, it like runs. If it makes a huge swap file, it's probably just data that it's loading because the CUDA memory is non-swappable. So this is all just interesting to understand what can be run in that device size, and that's a clever technique with presenting the CSI camera as webcam, so you don't have to change any of their G-streamer lines or anything.
Yeah. I'd say this is not strictly needed. I'd recommend people going with webcams first. It's much easier to work with. But I eventually wanted to mount a camera on the wrist of a robot arm, which seemed to present more data to the model. Hence, I opted for CSI camera.
Yeah.
Something small and
these motors, it probably can't lift a whole lot. So you putting additional weight of a normal USB camera, for those who haven't seen them, those Raspberry Pi MIPI CSI modules are very lightweight and would be great without too much affecting the manipulation.
Right. So and then there are some like small improvement to the robot itself. Those are like minor tweaks, but all now packaged into it. By the way, everything is now sort of on the JETSON AI lab page. So yeah, This page is updated last night. So this now primarily talks about the real world robots workflow. And I'm sort of walking people through all the necessary step you would need to take. Some are
Thank you.
optional, so you don't need
actually,
to do this.
yeah, you really built this out, and this seems more specific to like Jetson stuff, or like here's how you do the
Right.
UDEV roles, and then like step
Right.
into the Hugging Face tutorials. Like we get you all set up on like the Nano device, and you guys can take it from there because their tutorials are already great.
Right, right. Once you get into the phase of like really following the LeRobot official tutorial, you can pretty much rely on it. I'm just like providing tips, here and there.
Yeah.
So you can just like make a reference along the way. Take a look at it as you go. Okay, so all of those are already documented. Now let's see what it should do. So this is actually my very first try, and I was actually second, but like this is my real first try. First in the morning, because my Jax just finished training. I mean JAO, JETSON AGX Orin, trained this model overnight, and I came back. This is something I'm sort of like messing with the robot arm. It had already successfully completed, but I took it out and then see if it can still. And it timed out. I only give 30 seconds to like really perform.
Yeah, you should cap that because not the success most people just measure by just complete, but then the next metric is how many frames did it take, or that's what the actual industrial manipulation guys want to know is like, hey, was this thing really efficient at doing it? And I'm curious, have you been moving the brick around randomly or basically putting it back in the same spot?
Like when I'm testing, right?
Yes.
Like for the evaluation.
You randomizing anything.
Right. For training and evaluation, I've been placing the cube into many different places, different orientation, so that I can test if the model can like really learn.
That's key. Yeah. And maybe like randomize one dimension at a time and then add up as you get there. And it strikes me this would be really cool because I know you've been spending a lot of time manually assessing this and evaluating it, which all these research studies indicate it's physically very intensive. If you could somehow like automate the repositioning of the Lego and then put another vision language model to watch this and say, did it actually put the Lego in the bin or not? And then it could be fully automated for real world while working on like the simulator version.
That's a great idea. And yeah, I'm pretty sure we can come up with many clever ways to improve the efficiency of this whole process.
How many
certainly the way.
How many episodes do you typically evaluate it for when you're measuring the success ratios?
So for this, I went for 20 episodes to get 5%.
Yeah, not very. Yeah, it's not even.
Resolution.
Yes, and a lot of these papers, they do like 60 or 100, and then would claim like state-of-the-art improvements by 10 or 15%, which could be within margin of errors or things. So having more rigorous evaluation and benchmarking around these is needed, which is great because that's what LeRobot standardizes is like, here's all the data sets and the robot interfaces with that policies and stuff. So this is awesome. I know you've been putting a lot of time to really dive into this and show everybody how they can get started on the physical setup too.
Right. Talking about the evaluation, you can also record your evaluation session. So this is the 20 episodes I ran to evaluate this particular model. And yeah, it's kind of interesting. You can go back in the history to see if this particular episode was, well, this is Loki.
Real nice. Yeah, that's awesome.
Yeah, you see that this is being confused and sort of like repeating this motion. Like this particular position is probably not covered well, or the the model haven't like really learned to handle this particular plate. So this kind of gives us a sense that, oh, maybe the next time I would want to like include this kind of data set, putting a little more focus.
It would be interesting to know, like, if given the same amount of training time, like you allot 5 GPU hours or whatnot to each of the policies, how well does each one do in that given time or some other constraint like that? Because it might be diffusion policy gets that or struggles with another aspect.
True. Yeah, again, I haven't like really trained with diffusion policy, so that's another variable that I want to test. Yeah, it almost seems the infinite sort of combination of things that you want to test. One thing, one insight I got was you see this is the overhead camera, and the other is sort of like front facing camera over here. And oftentimes there are many like times, like especially on the top view, the object is being occluded by the arm itself. So if that was the case, it would like get much less sort of clue, right? And also, like this view is sort of like a capture from the distance, So it's not getting that much spatial resolution. Before this sort of dataset collection, I actually had a much wider field of view, and that didn't result good. So kind of shows that camera placement, camera resolution, or configuration matters a lot. So that's another thing you'd probably want to like change and test to see if that is effective. And that was the reason why I went for swapping out this camera with a wrist cam, because that should give a better sort of view most of the time. Keep the final object in the scope of the video. So that's what I did. I'm not sure if you can see, but this is a wrist cam. I'm gonna let you see the whole video, although this is not like performing well. So this is a view of the wrist cam. But like, yeah, as you see, it keeps the object in sight. And this is actually going to pick it up successfully. It's just that it got timed out.
Is it getting both camera feeds or just the wrist then?
Both. It relies on both.
Okay, that's nice. It can do multiple inputs, and I'll also look up here, like, how many frames of history does it get as well? Because
it should be referencing. I haven't like really dive deep into that, but yeah, it certainly like know what it was doing. And it's funny, you over time sort of get psychological attachment to your model. You feel like you're cheering for your model. Oh, you can do it! You can do it! Come on, baby! Kind of thing.
I felt the same thing when I like hooked Llama up to the ASR and the TTS the first time, or like the last time you really use models, because they have like a real limited shelf life these days. I'm like, or a TTS voice in particular. But I like the plexiglass like carve out you like made for this. You've did really nice with it.
There wasn't a good way to like really show that this is being all run on JETSON. So this is the way I opted out.
That's
seems
great.
to be working fine. Yeah, number of cameras. The framework seems to accommodate even more. So you can definitely try with more USB webcams. See if they can increase the accuracy.
Yeah,
But
and I'm sorry. Is this the one that you showed that 80,000 steps for, trained on 2 cameras? Because presumably that training will take longer, and maybe with one camera half the time or something.
Actually, this particular model, it went for overnight 220,000 epochs. I basically turned off the limit, so it's still going actually, but it almost have plateaued. I'm not sure if that would like really make a difference. But one thing I noticed was that, like, as actually ACT paper or the repo says, you want to train really for a long time, even after seemingly hit the plateau, because that actually like really makes the movement of the robot arm smooth. It used to be like jerky movement. I was testing 40K and 60K, but those were like really jaggy. But at 220K, it went much smoother. So I think that's the general sort of guidance, at least on ACT.
I think in the next 2 weeks, we can try to drop Torch to TRT in there, because this training does seem to be mostly done offline. So it's not, you don't need to keep the train version ready to go. You can convert it to TensorRT and probably get multiple times faster. And then I think it would smooth the motion out further. And I can see in the code here, it does, I think it's set up for 1 history step. And it says that it's a 640 by 480 vision model. Maybe that's just the encoder input. That's a lot higher than I was expecting, which is great. But
wasn't it the Resonate 18?
Yeah, I would think it was down to 224 by 224. That was just what ACT I've not super dug into yet, because like Nigel and you were on it. But suffice to say, a lot of these have trade-offs, certain characteristics, and I think of why you see a lot of people doing ensembles now out of these, or like hierarchical controllers where one's running fast and slow, and so there's a lot that we can all experiment with. And yeah, thanks to this setup, everybody can go get started with it. What else do you got there in your deck?
Yeah, I'm gonna just conclude. This is the whole setup. And yeah, the next step would be, like you have been mentioning, simulation would certainly be the area where people like to, go explore. That should like cut down the, time of like really needing to spend the time on all the physical setup. So that would be good. We could potentially even like make a contribution to back to LeRobot project. For the DGPU folks, at least, AB1 video encoder, hardware video encoder is available on, NVIDIA GPU at least. So yeah, if it can be used, it would speed up certain, segment of the time. My experience, I was spending like an hour for 200 episode amount of data, 2 streams, to encode the video into AC1, AV1. Yeah, so
that is good to identify those like easily solvable bottlenecks, either by like using a different codec or something. And when I did the OpenVLA thing, it was a similar story, just with other things. The data set transcoding from like Mimic Gen into RLDS, and somebody in the chat earlier said they made a converter from Mimic Gen RoboMimic format, which is HDF5, into LeRobot, so they could like skip some of this. But yes, it would take like, as long as it took to render all the sim or record it, it would take like convert the data. But messing with the data loaders introduce so many other variables that you're trying to control that you just like suck it up and let it take its time processing. But as we've been chatting, just iteratively refining these so the workflows get easier and easier, to the point that they could just be done by a normal end user, like you mentioned, in some Jupyter notebook or with speech commands. We will eventually get it to be that smooth, and all the refinement that you've done with the setup, I think, does a lot for it, for getting it into more people's hands.
Yeah.
Oh yeah,
I
Remy
wanted to.
said that would be good with the AV1
Oh,
GPUs. And a lot of this stuff
okay.
is like would benefit all the discrete GPU users too. Yes, in this group we tend to focus on JETSON because we're very interested in like edge computing and mobile robots. But I know like Hugging Face audience and LeRobot community is very large and has a number of folks that are just using normal discrete GPUs, and those torch to TFT optimizations would apply to them as well.
Right. If any of you are interested in, yeah, I would say, I mean, for the research, PC would be much easier. Although I have sort of like already took out some of the obstacle for you to get started on JETSON. But like if you are still intending to like explore many other, things, PC may probably provide a much flexible platform. So JETSON is actually great for building out the actual edge appliance or industrial solution. Many people have like expressed the interest of like making hardware enhancement to like this, or like coming up with a better interactive or progressive data capture, training, evaluation process. That would be nice. You should be also people suggested hardware button to hit record and then play. That would also make it a complete system, right? More close to the actual deployment. So when you are getting into that kind of gear and then making things into a final form, like a product or appliance, I believe JETSON is a great platform for that. Until then, you may want to get a little more speed up on PC platform. I think you can just work with a combination.
I think whatever you have available, really, it seems great for, and by virtue of it using PyTorch, it can do all those platforms. Like you say, if you're brand new and don't have anything to run this on and wanted to get started for the least cost possible today, I believe this setup is like the minimum viable that you can do, and it's like it does it in real time, and that's super important, as we found out from previous studies on these, that the control loop and feedback directly impacts the success ratio, and it will not be as accurate if it runs too slow, unfortunately. So yeah, and it might be that like, hey, the Orin Nano 8 GB, it can do ACT at this number of input streams, whereas the Orin NX could do diffusion policy or 3D diffusion policy in 16 gigabytes, and the AGX can do VLAs and whatnot. But having that scalability is pretty nice when it comes to putting these on actual edge devices. But for a lot of the reasons Chitoku mentioned and why there is all these containers around it, it is deploying stuff on ARM at the edge has its challenges. So to just get started and like pip install this, yes, it's easier on the desktop, but you can't always take your desktop with you, and that's where we're going with this. And by virtue of Dave's Humanoid, Chitoku's got the arm moving. We like combine this all up and put it on Stanley over there, and like actually do something with this, which is incredible. So I don't know if you have this set up live, if you want to try it. I don't know.
I may need to come back to give you a demo. Give you
well, you were having
demo.
screen share issues before. Yeah, that's fine.
Right. But I wanted to sort of like give a segue to what you were going to introduce. So this all, I mean, as of now, LeRobot is all demonstrating mostly, robot arm, right? But it got its inspiration from an Aloha project of DeepMind, and they showed mobile Aloha after that, which is mobile platform robot that moves around again autonomously in the sort of same behavioral cloning manner. So yeah, the possibilities are not just limited to this static, robot, but it may even like encompass such mobile robot, right?
That probably is like really important direction for us to go with this. Is like put this on a Create 3 or some other. I'm just saying that because that's the closest one that we already have, and see if we can go around the floor and pick up like the Legos as if it was like cleaning up your kid's room or something. And there you go. That's like an actual utilitarian thing that you're able to do and would be feasible. And that's also like what I'm interested in as well. While like high-end state-of-the-art researchers are doing amazing dexterous manipulation to solve really challenging problems, the fact that like you were able to get it to pick the Lego and maintain consistency over like a 200 frame episode, and I was able to get the VLA to stack the blocks, that is like good enough dexterity for us to go out and like try some basic utilitarian things. We don't need to be like cutting up veggies or stuff quite yet, because we probably don't even have the hands be able to afford it. So probably getting this on a mobile base sooner rather than later, and seeing what happens when it can actually go out and do stuff would be awesome.
Right.
Oh, he said it has support for Stretch 3. All right. Okay.
That's right. Yeah.
Okay. Yeah. Oh, cool. And I also know the Hello Robot guys, because they're in town, and Chris Paxton, and he has a mobile one of these too that's using very similar thing. And I think they did the PyTorch ROMs, and everybody's kind of in this like community doing it together. And yeah, that's awesome. Thank you so much for commenting, Remy, and know that you're busy. Good luck with your hackathon, and we'll keep on it from this side and apply optimizations and stuff. Okay, with the time that we have remaining, Chitoku, unless you wanted to cover anything else on your end, there was some quick questions we can cover quick. Like,
oh sure, I didn't get to cover.
How many cameras do people need? Like, they asked what CSI camera was, and I just said IMX.
Oh, right. Thank you for covering that. And on the list, I'm actually using a little wider field of view one, 160-degree field of view. In hope of capturing a better field of view, because it gets up close.
Okay, you did change the lens. All right.
Right.
Okay. And then there was another question about what platform did you teleop and data record it on? Did you do that on the Nano 2, or was that better experience on AGX?
Same. I use the same rig based on JETSON Orin Nano developer kit to capture the data as well.
Okay.
So, like I said, capturing the data, training, and inference, of course, all can be performed on this JETSON Orin Nano.
That's great. Yeah. And if that's all you had, you could have let it sit and train. It's just that when we're developing this, I think it's understandable that we accelerate it so we can get this project out to everybody faster. Right. Though you could just have run it on the Nano.
Yeah. It just gets into the cycle of you just like did it trained overnight on JETSON Orin Nano, and you wake up to discover what the state of the training.
It learned overnight when it was dreaming too, which could be an interesting model for this. Like over the day, you teach it, it collects these episodes. Overnight, it like fine tunes itself and picks that up. Brett had one question here: is what candidates for simulation are you considering? Isaac Sim ?
Oh, actually, Dustin, you have probably a better idea on this, don't you? I haven't like really explored the
I think since I kind of did a deep dive on Mimic Gen and all of those, you would wanted to like do the physical side, which is good because now we can show this is like you can actually do this on a real thing. I believe the LeRobot by default uses OpenAI Gym interface and Majoko simulator, and working them to integrate Isaac Sim, Isaac Lab, those other things. I believe there are a few people in the community that have done it. It is just basically that same gym interface that you can hook into everything, and everybody's just been going about like re-implementing those.
Yeah, there's a even discussion or at least a thread to, oh yeah, here is,
Yeah,
or
they just have some gym environments, and because I remember when we were building this, the sim for this was not difficult to build.
right. And
Yeah.
people do have interest in hooking this up with the Isaac Lab. I saw some threads going, on the Discord server of LeRobot. So that's another great resource if you are interested in diving into it. Yeah, you can certainly learn a lot from this community on Discord.
And yeah, I know some of our research scientists are working to get Isaac Lab and Isaac Sim built into this. And yeah, this uses Majoko and Gymnasium, which are great because that all runs on JETSON real easy and is what we've been using. Thank you everybody who joined today. If you have to drop off for your next meeting, please feel free to. Thank you, Chitoku and Remy, for all the commentary. Dave, I don't know if your camera is still working, if you wanted to try to come back on. I also know that NASA guys have wanted to chat about some of their latest enhancements with their ROS agents in Isaac. Maybe we might save that till next time at this point, given everything that's occurred here. But up to you guys. Any other questions, comments, feedback on the direction, or things you want to see, technical problems you've been having? Now's the time to ask. There was a question just came in. Are there larger arms that this could scale to, like industrial cobots? And I think the answer is like you can hook this up to anything. I believe it currently would use a IK solution underneath. Is that correct, Chitoku? What does it use to drive the IK now on the coach?
There's no IK.
No IK. It's outputting joint state.
Right. It's really copying or mapping the joint angle of each motors or servos.
Doing joint level. Okay. That is cool. Okay.
So that's something people start needing to look into once you use a simulator to build your data set using your globe or controller or Apple Vision Pro would like just capture your finger orientation. But then you do need to like really get the IK for your end movement.
Yes, and some of the other ones have. I'm sorry, was somebody trying to talk?
Oh yeah, can you hear me?
It sounds like it's background noise. Some of the other ones, there's a couple things people have been doing. One is relative deltas in EEF space. So the actual end effector, it says like, okay, move XYZ this frame. That was what the OpenVLA was using. Then these lower level ones that come out of reinforcement learning world seem to be more direct joint control. And then there's a third one that seems to be going with this like dual hierarchy where that's actually working in absolute EEF coordinates and just giving like a coordinate in the scene that says like, okay, go to this position on like the coffee handle of the cup because it only runs at like 3 to 5 FPS and then it uses an IK solver in between there. So as opposed to saying every little like frame doing it, it might only run once or twice a second and do a bigger jump because they're able to do like 3D absolute position. So there's a lot of different techniques you can try with like the coordinate spaces that these work in. And I know Nigel has had a lot of different things that he's done too, and also said that the absolute coordinates ended up working better. And I think that's also specific to like the different policies that are done. All right. Well, great work on this, Chitoku. I remember when I was doing the OpenVLA thing, it just seemed like it was going on forever, endlessly, and eventually had to prioritize like which avenue am I going down to explore next, and having some type of plan for like the research avenue that you're doing so you'll eventually get to where you want to go. Because when you're like running these experiments for days and weeks on end. The actual trajectory you're taking with it is like important, as well as all like the data you're collecting to remember it all. All right. Well, we will meet again in another 2 weeks on Tuesday, October 29th. Obviously, if there's any more questions, anybody would like to chat or ask Chitoku anything, feel free to stick around for as long as y'all want. In the meantime, I think Chitoku is going to continue working on this, and LeRobot, I will continue optimizing the policies, and we can see how fast that we can get some of these now that we have the base support in there. Also been looking at doing our own little miniature VLAs and VLMs out of different combinations of SLMs and vision encoders that you wish to have. Now that we have this data collection and recording thing, we can do those mini versions that like we had on the AGX, but for the smaller Jetsons. All right. So with that, we can wrap up the meeting for today. I'll stick around if anybody wants to chat for a few minutes after, but as always, thank you everyone for your support. Chitoku, all the great work. Yeah, and good luck up there with Stanley for for your Halloween, Dave, and let us know how it goes with that. Any help that or assistance you could use from the group, models or other things that you need, we'd be happy to help you be successful using that thing. So yeah, can't wait to see what you do with it. All right, thank you guys so much for all the great questions. Yes, yeah.
Oh, finally, I'm back.
Okay, you're back. Yes.
No.
Oh, he's back. Right as we were about to conclude. There he is.
Guess who's back?
Stanley's back.
Hey,
So
no,
funny.
I was watching all Chitoku stuff.
Yes. Thank you.
I shouldn't need any help with the Terminator stuff. However,
That's good. Okay, you can keep that like outside. We don't need getting this canceled. All right. Nice. It does. It does.
So what, yeah, it does. It does on its own. My floor is a bit slanted, so it kind of slowly fits forward, but it catches itself. It also doesn't need its head to work, which is nice.
Okay.
So I disconnected the head and restarted it, and it hasn't complained. So I can replace that with a full Terminator head, which will be nice.
All right. And does it have vision features or any like AI, quote unquote, out of the box, or are you enabled with the? I think you said ROS. It has earlier, right?
Yeah. So it has ROS 2 internally for controlling all the joints. By default, it's in like high level mode. You can give it general command velocities and it'll command the joints, or you can go into low level mode where you command each joint, you know, either position or velocity. Kind of the same as the Go 1 or the Go 2. It does have a stereo camera and a 3D LiDAR on its head, but when just walking, it doesn't use any of it.
Okay. Yes.
So in like out of the box high level mode, it doesn't use any of that stuff.
Right. Okay. So like obviously the entry point would probably be to add some vision on top of its existing locomotion system, as opposed to jumping straight into the deep end with RL, unless that's like really what you're going for with that. But do they have a simulator?
Definitely. Yep. So they have one apparently. It looks like so it looks like I can use that. One thing that I would probably like to do in the future would be I strap an AGX onto it and basically open it up to anyone in this group where, you know, train a model or don't, you know, and I'll just run it on the robot and you can see what it does.
You're a nice guy. Yeah. Well, maybe we have to like pass your sim first. If our model just doesn't like totally like trash your
Maybe, yeah.
robot, then it'll move on to or some like little competition or something.
Yeah.
That would be
some
so fun.
sort of mini gauntlet. I'll probably put its padding back on and pad the floor. But
All right, yeah, that's
I'm
hilarious.
pretty open to people trying it if they want to.
Okay. Yeah, I think that's a great idea for like engaging everybody and opening access to this for people that normally wouldn't have it.
Right.
Yeah, that's awesome.
So I guess whenever you come up here, Dusty, we'll do it then.
Okay, we will. Hopefully it's not the dead of winter that time by the time things finally calm down. But yeah.
It always is in Canada though. It's always the dead of winter.
It always is. Every time I've gone to like Boston and like MIT, it's been dead of winter also. So that's just how it'll end. So there have to be some like reinforcement learning demos for this at some point, or some similar ones that you could like get started with. Yeah, we can help.
I would assume so. As far as I know, this is the only humanoid. The only electric humanoid that can do a backflip, which was all done with reinforcement learning. So I'm going to reach out to Unitree and see if they will just give me the networks they made for that. If I can make it do a backflip, I can make it do pretty much anything.
Okay, well maybe start with like sitting down, or or if you put it on a gantry, or then obviously you can do whatever you want with it. But
they sent this like engine hoist with it. It comes in the box because this thing is I think 150 kilograms or something like that. Like it's stupid heavy.
Wow!
And you have to have it off the ground to turn it on.
Right.
So I'll make sure to keep my distance when it's doing its first backflip.
Yeah. And just for people's reference in the group, because we're all about having this be like normal people like us do this. Is this the base model, or I know these are known for being like the 10K production humanoid, quote unquote. What additional bells and whistles did you have to configure this with to be able to actually use it?
Nothing. So this out of the box as it stands right now is the vanilla H1. They only make one version of it. There isn't, like with the Go 1, there was the Air and the Pro, I think, and then the EDU. So there were different versions of it, which had primarily different software and some different hardware. But this, I believe there's only one version of it. It's meant for like research grade, like it's meant for research, nothing else.
Okay, cool.
The G1, which is like the little cousin to this, that one comes in a few different versions, I think, and it starts around 40 grand.
Okay, yes, all right. So this is the real kahuna, and like we understand that even to get in things now in like open environment, there is cost of doing business there, and I know there's a lot of people working on making these more cost accessible for everybody. And like Chitoku was talking earlier, you may not need full walking humanoid. We can still do mini embodiment models with like a JetBot. Create 3 and a little arm, which is probably more realistic to start. Like, what would this be, like a 36 degree of freedom, like embodiment model? If you wanted to RL all the joints, I don't even know adding them up, but I think like 32.
Yeah, there's 4 for each arm, and then you got 1, 2, 3, 4, 5 for each leg. So you've got 28, 29 with the hip or the waist.
Yes.
And then, so out of the box, each arm is only 4 axes. The hands are just kind of nubbins, but they do make 3 extra axes for each arm, which they're sending over as well. So that'll be, 28 plus 6?
34.
So 34?
So
34 axes when it's all done.
It's a lot, yeah. Considering we're currently trying to like simplify it a little bit to make the training easier and more predictable. So, and I know like the actual research teams are scaling this up to like the high. For example, with like the OpenVLA, it was very difficult to get it to actually function as advertised and do like cross embodiment and all of that. So we try a little bit more basic scenarios, or for example, with these mini VLAs, VLMs, we want to try just doing that on a small UGV to start, and then progressively adding more and more dimensions as you learn about the model until you end up with a 36D walking humanoid. And we'll see how much data it would take. But my guess is you'll be able to get it to do basic tasks and stuff without that much data, and probably spending some time just on the workflow to get it that like you can interactively teach the thing. Have you scoped teleoperation yet? Does this thing have prior perception and force feedback? Other things like that? I know Al in the group has been looking at teleop. I don't know. It doesn't look like he was here this week, but it previously been looking at Oculus. Do you have any ideas about that?
So I've actually recently been doing some remote arm control with VR, which is actually really promising.
There you go.
So maybe something along those lines would actually be doable. But I got this and then got derailed, so I've barely looked at it since I got it. I know that hung it up in my shop.
Yeah. Well, okay.
Yeah, hung it up in my shop, and I've done.
Really busy right now. Okay. Well, I mean that goes to you world one of 20, and you're just like so busy like everybody else. But I'm sure you'll get back to it. Yeah. And there's just as much of attention going into extended reality and all the teleop stuff, super low latency, as is going into like the model. So that tech's all very impressive. All right.
I actually brought this over to a friend the other day, and we were walking around. He's I'm going to say 170 pounds would be my rough guess, and he climbed on top of it and was on its shoulders, and it was holding his weight.
Okay.
Which
it is
insane to me.
Yeah. And Chitoku illuminated for me that it's these QDD motors that has enabled all of this tech, and we're want to do some basic examples of those too for people building up kits out of those. And I think it would be like you have that lazy boy tank thing, and I believe also like a horse carriage. That's where it would be funny if you had this thing on it and like driving that around. I'm sure you have infinite ideas.
Put a hat on it and see if I can pass it off with it on it.
Okay. All right. That's cool, man. It's just so interesting just to see how they work, and like the unboxing video. You can do like the unboxing for like the entire internet. You know, it'll be great.
I will be putting that together later today, actually, after this meeting.
Okay. Wow. All right. Well, be ready to get all kind of requests of people wanting you to do XYZ with it. That is so funny. All right. Thank you, Dave. Look forward to having you back, Stanley. Thank you. Yeah. I mean, this is incredible. Yeah.
I have two questions for Dave, if I may. First question. You mentioned simulation. What environment are you considering for it? I'm somewhat familiar with this robot that they have in Isaac Sim. Anyway, so what simulation are you looking at?
So it would be based on Isaac Sim. So I'm pretty sure under that it's like RL Gym.
Yeah.
Or
Isaac Lab. Yeah. And Chitoku and I have been working with like the granddaddy of that Animesh, Gaurav, and he did Orbit, which was like the predecessor. And I'm sure if, you get stuck or anything, we can bring him in. He's like, has a lot of accolades and stuff in that, and could help do this for real, and that is a good choice. Like on JETSON, sure, we use the other sims, but for this kind of thing, getting off with Isaac Sim from the bat will be good because you can scale it, and it might need that much like data and stuff for what you want to do.
In order to do that, to connect like Isaac Lab to Isaac Sim, so I've never done anything like that. Is it basically at the action graph layer that you need to basically create a whole, whatever we'd call that, a whole action tree that communicates?
Isaac Lab, it abstracts a lot of that away, along with like the environments, and is much like the OpenAI Gym interface, that whole step, get observation, reset type of simple control loop, and makes all of that a lot easier so you don't have to set up the full scene graph and assets in Isaac Sim and do all of the domain randomization and things of that nature. So it is aimed to make that process much easier than spinning up your whole own sim, essentially, within Isaac Sim. So it's just like an additional add-on for it that you can install. I believe the latest version is out now on GitHub. If you have any feedback or go and try that, please don't hesitate to let us know so we can more quickly incorporate all of that into things. And yeah, we're all getting set up with that too, because eventually that, like, they are working on all of this now and have labs with these humanoids and scaling it up to massive infrastructure level simulation training and deployment that it would take to make like an actual foundational model. But we perhaps in the meantime could get started learning all of this stuff and do more like focused utilitarian ones that like Chitoku collected just for his, or Dave collects it just for his and his environment, and still very capable and powerful. Maybe like we're not going to go train our own generalist foundation model because we don't have the computer time for that. But just like the LeRobot guys, they're able to like very focused do it with an easy workflow for it. So have fun with that thing, Dave. Is there any other questions to ask? I mean, don't often get a humanoid right there to chat about.
I have one more question for Dave.
Yep.
I know, we talked earlier about the high level interface or API that Unitree offers, and then the low level one. My read on it was that all the action is at the low level one, where you can do anything, right? All the sensors and all the joints are at your disposal. But it was my assessment at the time that there was no library that one could point to as something like simple that was already working that you could get started with the low level one. Wanted to see if that was still, if you felt that assessment was accurate, or if you had a recommendation for some type of example repo that interacts with it at that low level.
So I haven't really dug into this super deep. I know with the Go 1, they had a library that you could use, but it didn't work great.
Right.
But then again,
it's hard for anybody to do the whole thing, Yeah. You said it has the ROS nodes, right? So
yeah, so it is running ROS internally. So you run Cyclone and you just say ROS2 topic list, and it's all
that's
there.
pretty sweet. Yeah, kudos to them for that. That's like open, and you don't got to deal with all the drivers and everything. So like, yeah, if you want to do full embodiment, like pixels to joint states, then that is like the end all be all. There is other schools of thought also, like Abrar's Remember project, right? That integrated vision language models and Gen AI on existing robotic stack. So you could just put like a VLM, a function calling VLM on the thing that told it where the next place to go, or simultaneously on the flip side, do the full embodied model and like compare and contrast the two. Eventually, maybe those policies would like be in this hierarchy together. A lot of people are saying they're doing same approaches as that.
So looking at their SDK, because this is ROS 2, it uses their SDK 2. For each axis, you can specify position, velocity, acceleration, the K, so the P and PID gains.
Okay.
Yeah. So you could specify all of that for each axis. And what rate is it that? It's usually for them, it's like 500 hertz. Yeah, it's 500 hertz.
Okay. Ooh. Yeah. Well, what system does it run on board? Is it like a NUC or another real-time?
No, they have 3 x86 machines in there.
Okay. Well, what are they all doing? Can you clear them out and put like Orins or Thors in there? Or like, yeah.
You have some Thors you're offering? Is that
I don't? Yeah. If we go on with this group, we like, let's see, that is supposed to come out like next year, and it's been starting to be presented more. I talked about it last week in DC. So yeah, we're starting like the bring up work on that, and it's meant for humanoids, Dave. And you've got a humanoid and a social media following. So yeah,
I know a guy.
Yeah. Well, and it sounds like Brett may be interested in this low-level control, and perhaps you guys could work together to. This whole remote development thing is interesting because this group is global too, and we could do round-the-clock action on this. So, thanks for being willing to like share all of that information. It's enlightening.
No problem. Yeah, there's. Apparently there are two of the x86 computers are, one of them is doing all of the motion control, and I think the other one's doing all the perception. Then the third one doesn't do much, and it's meant as
it's like the payload.
Right. It's meant as like the application computer for development. So,
well,
I mean,
we can
there's
just leave
also
all
space.
that.
Yeah.
Okay.
And so I can leave all of that there, run a bunch of stuff on the internal machine, or there's even space, like I could give it a backpack with a JETSON or 2 in it. Whatever.
Yes. Yeah. If you get and maybe even Wi-Fi right now, like you can, I know your, fabrication skills are very strong. So you could start with it on, half the time we just have the thing on Wi-Fi. It's once the thing starts going mobile inside your house or whatnot, that's really when you need to bolt the thing to it. But and how long's the battery life? I meant to ask you that.
Decent. I had it walking around solidly for at least an hour. Wow. And it still had more than half of its battery. So in terms of like actual walking, it's at least 2 hours, if not more.
Great. You gotta take this thing around town with you. And given the Tesla Optimus, you see all that launch where it was actually like teleoperated, and a lot of the people were like, the teleoperation was really good. Like the actual research scientists were amazed at the hardware quality, whereas everybody else was like, oh, it's not autonomous. But even just taking this thing out in public, I bet you would get quite some social reactions. But it is kind of part of our role as the early pioneers of this to go about it responsibly, preparing people for like these type of robotic machines. And we're fortunate to be the ones to get to, promote open source solutions, open stack, accessible education, all that. We're lucky to get to be those guys. And that's incredible. So this is some crazy fairy tale keeps evolving. Now you have a humanoid. We're like, we did this big partnership with CMU this week. It's like nuts, everything that's going on. So all right, well, I can't wait to see this thing again in another 2 weeks. If you need anything in the meantime or want to run other meetings about this, make it go faster to the extent that you can, other group members you want to coordinate with, we would love to. It would be hilarious if we got LeRobot to run on that. This is like the HuggingFace humanoid, and you can put like the big smiley face on him. Okay.
I've had multiple requests to put googly eyes on him because people find him creepy.
Yes, and to that point, perhaps they could design some of these to be more like Disney and less, sci-fi. And actually like the most popular post I ever had was posing with that little Disney BDX robot at GTC, and I love that. The kids made me promise that I would get a picture with that, and there's 3D printed ones of them out now too that are kind of similar and use those same servo technologies. So,
well, the ETH Zurich guys released a paper about all the reinforcement learning training they did to use animations with with a policy. So I'm hoping to port basically that paper onto this robot.
Okay.
So I can teach it to Davis.
Chris and I met the guy at GTC. He came out for like beers with us, and he's like, "Yeah, I've got like 4 of them back in my hotel right now." And the guy from Disney that was like operating it, because he did all.
He was fantastic. I mean,
do you still keep in touch with him, Chris?
Yeah, we haven't talked, I don't think, since the event, but we spent most of that evening just hanging out and talking shop, and those guys, awesome. They're academics, and so most of them are very open to sharing all of the information they can. I mean, you see them publish papers and all.
I bet you could 3D print some cool exoskeleton for this, Dave, and make it like some Disney character.
Dave, that would just go straight to T1000 and just call.
I know, he's just getting that out of the way. It's Halloween. Yeah. It's all. Even I understand. Just like rip the Band-Aid off, Dave. Your Dave's Armory. Yeah,
I mean, that is the spookiest thing I can think of is Skynet. So I might as well just do that.
Just make it funny. Yeah.
Dave, you and I will talk offline. I got a good idea for the next one.
Please do, wonderful. Chris. 2 weeks from now, Dave's on the front page of Gizmodo and every other publication, along with oh boy, this is awesome and a great opportunity for us. So, all right, I'll let you guys know. You guys go. It's now 30 past the hour. We'll see you again next time, Stanley. And thanks for the demo. Thanks, Chitoku, for all the work. Johnny, for all the containers.
Thanks.
We'll see you guys again in another 2 weeks. It is getting, really amazing here with all this going on. So thank you guys. Drop off.
Thank you, everybody.
Bye,
Have a great
day,
everybody.